The stone cut so perfect it shouldn't exist in the ancient ruins of Pumapunku, Bolivia, at an altitude of 12,800 feet in the Andes Mountains. There sits a stone block that has baffled archaeologists, engineers, and geologists for over a century. This isn't just any carved stone, this is a piece of andesite, one of the hardest volcanic rocks on Earth, cut with such precision that modern laser measurements reveal tolerances of less than 1 millimeter across surfaces spanning several meters. The edges meet at perfect 90-degree angles. The surfaces are so flat and smooth that when placed together, two blocks form a seal so tight that not even a razor blade can fit between them. The drilling shows characteristics that shouldn't be possible with the copper and stone tools that mainstream archaeology attributes to the Tiwanaku civilization that supposedly created these monuments around 500-900 AD. When modern stonemasons are shown these blocks and asked to replicate them using the tools available to ancient cultures, they consistently say the same thing. Impossible. Not difficult. Not challenging. Impossible. Even with modern diamond-tip tools and computer-guided machinery, achieving this level of precision in andesite is technically demanding. Yet here it stands in a windswept plateau in the Andes, created by a civilization that supposedly had no written language, no wheel, and only the most primitive metal tools. Today you're going to discover exactly what makes these stone cuts so extraordinary, what modern analysis has revealed about how they were created, why conventional explanations fail to account for the evidence, and what these ancient blocks might tell us about technologies we assume didn't exist in the distant past. This is the story of the stone that shouldn't exist, and once you understand the engineering involved, you'll never look at ancient civilizations the same way again. The precision that defies explanation. To understand why the Pumapunku stones are so remarkable, you need to understand precision engineering. In modern manufacturing, precision is measured in tolerances. How much deviation from perfect is acceptable? For most construction, tolerances of several millimeters are fine. For automotive parts, you need tolerances within tenths of a millimeter. For aerospace components, you might need precision within hundredths of a millimeter. The Pumapunku blocks achieve tolerances that would be acceptable in modern manufacturing. Except they're carved in andesite, a material with a Mohs hardness of 7 out of 10. For context, copper, which mainstream archaeology says was the hardest metal available to Tiwanaku culture, has a Mohs hardness of about 3. You cannot efficiently cut or shape a material with tools softer than the material itself. It's like trying to cut steel with aluminum. The physics simply doesn't work. Yet the stone blocks at Pumapunku show characteristics that are difficult to explain even with hard metal. Tools. In 2014, a team of engineers from the Colorado School of Mines conducted detailed measurements using laser scanning technology and 3D modeling. Their findings were startling. Surfaces that appear flat to the human eye are flat to within 0.5 millimeters across spans of 2 meters. The corners meet at angles that deviate less than 0.2 degrees from perfect right angles. Holes drilled through the stone are perfectly cylindrical with no taper and no tool marks indicating progressive drilling. The surfaces inside these holes are so smooth that they appear almost polished. Dr. Jennifer Martinez, a materials engineer who participated in the study, noted in her report, "If I encountered these tolerances in a modern machine shop working with softer materials, I would assume computer numerical control manufacturing. In andesite, at this scale, with these finished qualities, I'm at a loss to explain the methodology. The most perplexing features are the so-called H-blocks, massive stones, carved into interlocking shapes that allowed them to be fitted together without mortar. These blocks have protrusions and recesses that match with precision measured in millimeters. Creating such tight tolerances requires not just good tools, but measurement systems capable of detecting deviations smaller than the human eye can see. How did ancient peoples, supposedly without advanced mathematics or measurement instruments, achieve this? The conventional explanation is patience and skill, given enough time and careful work, the argument goes. Ancient craftsmen using primitive tools could achieve these results. But this explanation fails when you examine the actual characteristics of the cuts. Patience and skill can create smooth surfaces, but they create smooth surfaces with specific signatures, tool marks, progressive refinement patterns, and slight variations in flatness. The Pumapunku stones lack these signatures. They look machined, not handcrafted. They look like they were created with technology, not with time and effort. If you're starting to realize that ancient history might be far more advanced than we've been taught, you need to subscribe right now and hit that bell icon. Drop a like to help this evidence reach more people who question official narratives. Click the hyper button below to support our investigations into what mainstream archaeology won't address. Your support makes this research possible. Now, let's dive deeper into what these stones really tell us. The material science nightmare andesite is not just hard, it's also brittle and contains crystals of varying hardness embedded in a volcanic glass matrix. This makes it exceptionally difficult to work with. When you try to carve or drill andesite with tools that aren't significantly harder than the stone, one of several things happens. First, the tool wears down faster than it shapes the stone, making the process absurdly time-consuming and requiring constant tool replacement. Second, the stone tends to fracture rather than cut cleanly, especially when you're trying to create sharp edges or smooth flat surfaces. Third, crystals within the stone can cause tool deflection, making it nearly impossible to maintain straight lines or flat planes over large areas. Modern stonemasons working with andesite use diamond tools and water cooling. Diamond with a Mohs hardness of 10 is one of the few materials that can effectively cut andesite without excessive wear. Even with diamond tools, creating the precision seen at Pumapunku would require computer-guided equipment and constant measurement. So how could ancient peoples achieve this with copper tools? The conventional explanation relies on a technique called pecking, where you repeatedly strike the stone with a harder stone hammer, gradually wearing away material. For softer stones like limestone or sandstone, pecking works. It's slow, but it's effective. For andesite, pecking is problematic for several reasons. First, you need hammerstone significantly harder than andesite, which limits options. Quartzite or jade might work, but these are rare and precious materials. Using them to peck away at massive andesite blocks would require enormous quantities. Second, pecking creates a characteristic surface texture, a dimpled or pitted appearance. While this can be smoothed with abrasion, doing so on andesite would be incredibly time-consuming and would leave traces of the process. The Pumapunku stones show no such traces. Their surfaces transition from perfectly flat planes to perfectly cylindrical holes with no indication of progressive refinement. In 2009, researcher Jorge Calvo conducted experiments attempting to replicate Pumapunku precision using authentic pre-Columbian tools and techniques documented by archaeologists. Working with andesite samples of similar hardness, he spent 6 months attempting to create a single flat surface 1 meter square with precision comparable to the ancient blocks. His conclusion: using the tools and techniques available to the Tiwanaku culture as understood by mainstream archaeology, replicating these results is not feasible within any reasonable time frame. Either the Tiwanaku had tools and techniques we don't know about, or these stones were created by a different culture with more advanced capabilities. This raises an uncomfortable question. If the tools we think they had couldn't create what we see, what tools did they actually have? The impossible drilling evidence. Perhaps the most compelling evidence of advanced technology at Pumapunku comes from the drilled holes. These aren't crude indentations or rough bores. These are precision drilled holes that display characteristics that shouldn't be possible with primitive technology. The holes are perfectly cylindrical from entry to exit, with no taper whatsoever. In hand drilling with primitive tools, some taper is almost inevitable as the drill wanders slightly during the process. The holes at Pumapunku show no such wandering. The holes have smooth interior surfaces with no spiral tool marks. Modern drilling with rotary tools leaves characteristic spiral grooves as the bit advances through the material. Ancient drilling with bow drills or pump drills, which rotate back and forth, leaves different but equally distinctive marks. The Pumapunku holes show neither pattern. Some holes pass completely through blocks over 1 meter thick, maintaining perfect alignment and diameter throughout. Drilling through such thickness in hard stone with primitive tools would require withdrawing the drill repeatedly to clear debris, and each reinsertion would risk misalignment. Yet the holes show no evidence of misalignment or diameter variation. Most puzzling are holes that intersect at precise angles within the stone, creating internal channels. This requires not just drilling, but the ability to calculate and execute entry points and angles with great accuracy. Modern Cordova Drilling can achieve this, but it's a sophisticated process requiring careful planning and measurement. In 2016, engineer Chris Dunn, who specializes in precision manufacturing, examined the drilled holes at Puma Punku using advanced metrology equipment. His findings were published in a detailed technical report. The holes showed feed rates, the speed at which the drill advanced through the stone, that were consistent and rapid, approximately 2 to 3 millimeters per revolution, based on analysis of what microscopic features existed. This is fast for andesite, even with modern diamond core drills. Achieving such feed rates with copper or stone tools would be physically impossible. The cutting forces required would shatter primitive tools long before they could advance at that rate. Dunn's conclusion: the holes at Puma Punku display characteristics consistent with high-speed rotary drilling using hard abrasive or diamond-impregnated tools. No known ancient technology can account for these features. Some researchers have suggested that perhaps copper tubes charged with sand or other abrasives were used, a technique known from ancient Egypt. While this can drill holes in hard stone, it produces specific signatures: slow feed rates, rough interior surfaces, and circular striations. The Puma Punku holes show none of these characteristics. They look like modern machine drilling, which is precisely what makes them so anomalous. The advanced mathematics hidden in stone. The precision of the cuts is remarkable, but perhaps even more remarkable is the geometry. The blocks at Puma Punku aren't simply flat slabs. They're complex three-dimensional shapes with multiple surfaces meeting at precise angles, with protrusions and recesses designed to interlock with other blocks. Creating such complex geometries requires not just good craftsmanship, but advanced mathematical understanding. You need to be able to plan the shapes in advance, ensure that corresponding blocks will fit together, and maintain precision across multiple dimensions simultaneously. The level of geometric sophistication implies understanding of concepts like three-dimensional coordinate systems, angular measurements, and possibly even principles of descriptive geometry that weren't supposed to be formalized until much later in human history. Dr. Robert Schoch, a geologist who has studied Puma Punku extensively, points out that the interlocking blocks required a level of planning and mathematical precision that suggests either a very advanced indigenous culture or influence from an as yet unidentified source with sophisticated knowledge. The H blocks in particular demonstrate astonishing geometric planning. These massive stones, weighing several tons each, have complex profiles that allow them to lock together in specific orientations. The male protrusions on one block fit into the female recesses of another, with clearances of only 1 to 2 millimeters. This means that when these blocks were designed and cut, the craftsman had to ensure that dimensions across different blocks matched within very tight tolerances. In modern manufacturing, this is achieved through careful measurement and often through creating detailed plans or CAD models. How was it achieved at Puma Punku? Some researchers have analyzed the dimensions of various blocks and found evidence of standardized measurements, suggesting a consistent system of units. The presence of such standardization implies a degree of organizational sophistication and mathematical formalization that challenges conventional narratives of the Tiwanaku culture. Moreover, the layout of the Puma Punku site itself shows geometric relationships that seem too precise to be coincidental. Alignments with cardinal directions, ratios between dimensions of different structures, and spacing that appears to follow mathematical progressions have all been documented by various researchers, though interpretations vary. Whether these patterns were intentional or are examples of humans finding patterns in randomness remains debated, but the precision of the stonework itself is undeniable. When orthodox chronology falls apart, mainstream archaeology dates Puma Punku to roughly 500-900 AD, placing it within the Tiwanaku culture period. This dating is based primarily on pottery styles found in the area and radiocarbon dating of organic materials from nearby contexts. But here's the problem: the precision stonework we've been discussing doesn't match the technological capabilities attributed to the Tiwanaku culture in that time period. This creates what archaeologists call a chronological anomaly. We have evidence that doesn't fit the timeline. There are several possible explanations, each with implications. First possibility: our dating is wrong. Perhaps the stones are much older than the Tiwanaku culture, created by an earlier, more advanced civilization that we haven't properly identified. The Tiwanaku people may have simply built around ruins they found. This would explain the precision, but requires accepting that South American history has major gaps. Second possibility, the Tiwanaku culture was far more advanced than we've recognized. Perhaps they had technologies that left no trace in the archaeological record, or that we haven't found yet. This would mean reassessing our entire understanding of pre-Columbian American civilizations. Third possibility, the stones were created with help from outside the region, either through trade and knowledge transfer from other advanced cultures, or through contact we don't have records of. This opens questions about ancient global networks. Fourth possibility, and most controversial, the stones represent evidence of technology from a civilization that predates all known history, perhaps from before the last ice age ended around 11,000 years ago. This is the lost civilization hypothesis that mainstream archaeology largely rejects, but that these precision stones seem to support. Geologist Robert Schoch has argued based on weathering patterns that some structures at Pumapunku may be much older than conventionally believed, possibly dating to 12,000 or more years ago. Weathering analysis is not definitively conclusive, but it raises questions that conventional chronology struggles to answer. The precision of the stonework becomes even more anomalous if the structures are indeed older, as it would push sophisticated engineering back to a time when humans supposedly hadn't even developed agriculture yet. The chronological problem is compounded by the fact that no clear evolutionary sequence of technology is evident at the site. Usually when a culture develops a new technique, you can trace its development through progressively more sophisticated examples. At Pumapunku, the most precise stonework doesn't show this progression. It appears fully formed, with no evident period of experimentation or refinement. It's as if the builders already knew how to achieve these results before they started. The global pattern of impossible masonry Pumapunku isn't alone. Around the world, there are sites with stonework that displays similar anomalous precision, often attributed to cultures that supposedly lacked the technology to achieve such results. In Egypt, the Serapeum of Saqqara contains massive granite boxes weighing up to 100 tons, hollowed out with interior dimensions that vary by less than 2 millimeters across spans of 3 meters. The interior corners are perfectly square. The surfaces are nearly optically flat. Mainstream Egyptology attributes these to the Old Kingdom, but no credible explanation exists for how they were created with copper tools. At Baalbek in Lebanon, the foundation of the ancient temple complex includes stones weighing over 800 tons, precisely cut and fitted. 3 stones, known as the trilithon, weigh approximately 800 tons each and are positioned at a height of 7 meters, fitted so precisely that joints are barely visible. No ancient civilization is known to have had cranes capable of lifting such weights. In Peru, the fortress of Sacsayhuaman near Cusco features megalithic walls with stones fitted so precisely that a knife blade cannot be inserted between them. Some stones have dozens of angles and faces, all fitting perfectly with adjacent blocks. The precision is comparable to Pumapunku and equally unexplained by conventional means. On Easter Island, in addition to the famous statues, there are precisely cut basalt stones that show drilling and fitting techniques similar to Pumapunku, despite the island's isolation and limited resources. In Japan, the underwater structures off Yonaguni show what some researchers argue are cut stones with right angles and flat surfaces, though the interpretation of these features remains controversial. The pattern across these sites is consistent: precision stonework in the hardest materials, using techniques that remain unexplained, attributed to cultures that supposedly lack the necessary technology. This global pattern suggests either that multiple independent ancient cultures developed advanced stoneworking technologies that we've failed to recognize, or that there was a common source of knowledge that spread across the ancient world. Either possibility requires reassessing conventional historical narratives. The alternative, that all these sites are coincidental, that primitive tools really could achieve these results if people were just patient enough, strains credibility when you examine the actual physical evidence of the stone cuts themselves. Modern attempts to replicate ancient precision. Over the past few decades, various researchers, engineers, and even television shows have attempted to replicate ancient precision stonework using only tools and techniques available to ancient peoples. The results have been consistently revealing. It's extraordinarily difficult, and the finished products don't match the Ancient examples. In 2012, a team of stonemasons in Peru attempted to replicate a section of Incan wall using traditional techniques. After weeks of work, they achieved decent results, creating fitted stones that demonstrated skill. However, close examination revealed that their precision was an order of magnitude less than the ancient walls. Gaps between stones were visible, surfaces weren't perfectly flush, and the overall fit was noticeably inferior. The masons acknowledged that achieving true ancient-level precision would require modern tools. In 2015, archaeologist experiments at replicating Pumapunku precision using copper tools and abrasives produced results that were nowhere near the tolerances of the original stones. After months of work, the best they could achieve were surfaces with millimeter-level irregularities and visible tool marks, far from the near-machined quality of the Pumapunku blocks. Engineer Christopher Dunn conducted experiments drilling granite using copper tubes and sand, attempting to replicate the technique that Egyptologists claim was used for drilling in ancient Egypt. He found that while the technique does work, it produces holes with characteristics distinctly different from the ancient holes. Much slower feed rates, rough interior surfaces, and distinctive circular scoring marks. The ancient holes at Pumapunku and Egyptian sites don't show these characteristics, suggesting a different technique was used. Television shows attempting these replications often present impressive feats of moving or shaping large stones, but upon close examination, the precision achieved is always far below that of the ancient examples. This isn't to diminish the impressive skills of modern craftspeople attempting these replications, but rather to highlight that the ancient results represent something beyond what we can replicate with the tools we believe they had. The consistent failure to replicate ancient precision using ancient tools leads to an inescapable conclusion. Either the ancients had tools and techniques we don't know about, or our understanding of which cultures created these works is incorrect. Neither option is comfortable for conventional archaeology, which is perhaps why these replication failures don't receive more attention in mainstream discourse. The technology they don't want to acknowledge. If primitive tools can't explain the precision at Pumapunku, what can? Several researchers have proposed technologies that would have been capable of creating these results, though acknowledging these technologies requires accepting that ancient capabilities were far beyond what's conventionally recognized. One possibility is advanced abrasive technology. Modern ultrasonic machining uses high-frequency vibration combined with abrasive slurry to cut hard materials with great precision. No evidence of ancient ultrasonic technology exists, but the characteristics of some ancient cuts are consistent with this type of process. If ancient peoples had developed sophisticated abrasive techniques using hard stone powders and some form of mechanical agitation, they might have achieved results that appear machined. Another possibility is that ancient metallurgy was more advanced than we recognize. If cultures had access to very hard alloys, perhaps iron or steel-like materials that didn't survive in the archaeological record, they could have created tools capable of working andesite with precision. The problem with this theory is that while bronze and even early iron cultures existed in the Old World during the relevant time periods, there's no evidence of such metallurgy in pre-Columbian South America. Some researchers have proposed that ancient peoples had access to chemical or sonic techniques for softening or fracturing stone in controlled ways. Laboratory experiments have shown that certain frequencies of sound can cause fracturing in crystalline materials, and some chemical processes can alter the hardness of stone surfaces. While these phenomena exist, evidence that ancient peoples knew and used them remains speculative. The most radical proposals involve acknowledging advanced civilization predating known history. If a technologically sophisticated culture existed before the end of the last ice age, they could have possessed a range of capabilities, including precision machining, advanced mathematics, and engineering knowledge. The precision stonework would then be remnants of this lost civilization. This hypothesis is rejected by mainstream archaeology primarily due to lack of other evidence for such a civilization, though proponents argue that much evidence could have been destroyed by the catastrophic climate changes at the end of the Ice Age. Engineer Christopher Dunn has proposed that some ancient sites, including the Giza pyramids and possibly Pumapunku, are remnants of civilizations with technology comparable to our modern capabilities. His analysis of tool marks, precision, and scale of projects suggests advanced machinery. While his specific proposals remain controversial and unproven, his technical analysis of the precision itself is harder to dispute. The reluctance of mainstream archaeology to seriously consider these possibilities stems partly from the evidence problem. We don't have the tools, we don't have clear records, and accepting advanced ancient technology without such evidence challenges fundamental paradigms. But the stones themselves are evidence, and they tell a story that current models struggle to explain. What this means for human history. If we take the evidence of precision stonework seriously and acknowledge that conventional explanations are insufficient, we're forced to reconsider fundamental assumptions about the development of human civilization. The standard narrative is that humans progressed linearly from primitive hunter-gatherers to agricultural societies to civilizations with writing, cities, and technology. This progression took thousands of years and followed a relatively consistent pattern across different regions. The precision stones suggest a different narrative, that human capabilities have not always progressed linearly, that there may have been periods of advancement followed by regression, and that some ancient peoples possessed knowledge and technology that was subsequently lost. This is the cyclical view of history, where civilizations rise, fall, and their achievements are forgotten, only to be rediscovered later. Evidence for this cyclical pattern appears in multiple contexts beyond stonework. Ancient astronomical knowledge evident in site alignments and calendars suggests sophisticated mathematical and observational capabilities. Ancient metallurgical techniques that produce materials we struggle to replicate indicate advanced material science. Ancient construction methods that moved stones weighing hundreds of tons demonstrate engineering prowess we can barely match today with modern equipment. If history is cyclical, if advanced civilizations have existed before and been lost to cataclysm or gradual decline, then the precision stones are not anomalies but reminders. They're durable evidence of capabilities that once existed, survived the collapse, but that subsequent cultures couldn't replicate because the knowledge base was lost. This would explain why so many ancient sites show the most impressive work in their earliest phases, with later additions being distinctly inferior. It's not that later peoples were less skilled, but that they were trying to work with ruins from a more advanced era, not understanding how the original work was accomplished. The implications extend to how we view indigenous cultures. If the Tiwanaku or other pre-Columbian peoples were inheritors of more ancient traditions, possessing fragments of lost knowledge, then we need to take their own oral histories and legends more seriously. Many indigenous traditions speak of a distant time when the gods or ancestors possessed great powers and built the ancient monuments. Mainstream scholarship treats these as mythology, but perhaps their cultural memory of real events involving real technologies. For modern civilization, the precision stones are both humbling and cautionary. They humble us by demonstrating that our ancestors were capable of things we arrogantly assumed only modern technology could achieve. They're cautionary because they remind us that sophisticated civilizations can fall, their achievements can be forgotten, and progress is not inevitable. Whatever created the precision at Puma Punku was capable of engineering we struggle to match, yet that capability was lost. Could our own technological civilization someday be reduced to ruins that puzzle future archaeologists? The questions that remain unanswered. Despite decades of study, fundamental questions about Puma Punku and similar sites remain without satisfactory answers. How were the stones cut with such precision? We can describe what we observe: flat surfaces, tight tolerances, smooth holes, but we cannot definitively explain the methodology. Every proposed technique using available ancient technology falls short when tested experimentally. How were massive blocks moved and positioned? Some Puma Punku stones weigh over 130 tons. Moving such weights requires sophisticated engineering even with modern equipment. Proposed ancient methods like rollers, sledges, and ramps are theoretically possible, but practically dubious for stones of this size, especially given the high altitude terrain. Why was such precision necessary? For structural purposes, the level of precision at Puma Punku exceeds what's needed. Less precise stones would function perfectly well as building materials. This suggests that either the precision was aesthetically important to the builders, or it served some functional purpose we don't understand, or the builders were capable of this precision. and simply worked to their capabilities. When were the stones actually created? Conventional dating says 500-900 AD, but this dating is indirect and based on context rather than the stones themselves. Some researchers argue for much earlier dates based on weathering, geological, and astronomical considerations. Without definitive dating methods for the stones themselves, uncertainty remains. Who created them? The conventional answer is the Tiwanaku culture, but if the Tiwanaku lacked the technology to create these precision cuts, then either we've misunderstood Tiwanaku capabilities, or the stones were created by a different unknown culture. What happened to the knowledge? Even if we accept that ancient peoples created these stones with unknown techniques, we must ask why the knowledge was lost. Skills and technologies usually persist if they're useful. The disappearance of precision stoneworking capabilities suggests catastrophic cultural disruption, or the loss of key technologies that the skills depended upon. Are there other sites we haven't discovered? If precision stonework was a widespread capability in the ancient world, there may be many more sites that haven't been found or haven't been recognized for their significance. Much of the world remains archaeologically unexplored, and erosion, vegetation, and later construction may hide ancient remains. These unanswered questions ensure that Puma Punku will continue to fascinate and perplex researchers. They represent the frontier where our knowledge meets the unknown, where evidence and theory diverge, and where we must remain humble about how much we really understand regarding ancient human capabilities. If this evidence has opened your eyes to the possibility that ancient civilizations were far more advanced than we've been taught, hit that like button now to help others discover this suppressed history. Subscribe and turn on notifications for more investigations into ancient technologies that challenge everything. The video appearing on your screen right now explores similar impossible engineering at other ancient sites. You need to see the connections. Thank you for questioning the official narrative with us and seeking the truth about our ancient past. The stones speak if we're willing to listen.